over 15, that reduces to 2/3. 20 over 25, that's 4/5. You can see those are not the same. They are not the same. And that's where we're saying maybe it's not proportional. Okay. And the oddity about your class is they always seem to start out with one that doesn't work rather than giving you one that does work. Okay. So in your class, the proportional relationship you're looking at is this y equal kx, and the that hasn't been spelled out for you. It is what they're looking for here. X is the original price, Y is the sale price. For it to be proportional in your problems here, Y over X is going to be the same in each. Do you have a calculator handy? Are you allowed to use one in this class?
Yeah.
Okay. Could you calculate 12 over 15, 20 over 25, and 28 over 35 for us, please?
All of them are 0.8.
They're all 0.8. So when all of these are the same, there is a proportional relationship. And that was the issue with the last one. The last one, they were not the same. 2/3 and 4/5. Without even calculating it, we know that it is the that is an issue. So the next thing it says is to actually calculate the proportionality constant. And we've actually already done it here, but the more formal way is to write the equation y equals kx. This is constant, what's called constant variation. Maybe that looks familiar to you. And then to
Yeah.
use one of these x and y values. So I'm going to choose the middle one here. That looks the nicest to me. So that's 20 equals k times 25. To solve this equation, you divide both sides by 25. And you can see that k equals this 20 over 25, which is 4/5, which is 0.8. That's what they're looking for. All right. Any questions, thoughts on that before we move to 2?
No.
Okay. I started looking at 2 and I was very unclear about what they wanted, and I looked at it again and again. I think I understand what they're wanting. Again, it's just a really odd way of presenting this. They're saying there's some reference point to the ground, and the bird is currently at 20 meters from the ground. That's the bird. And then changes, in this case, because it's positive, this means it's going up. So it's like it's going up another 16 meters here. And they want you to figure out its final elevation. So basically you have to figure out from the starting, you take the start and you add to it the change. So in this case, it started at 20 and you add the 16. So its final height would be 36 meters. And that's because it's going up, positive. Now in part B, which was kind of the oddity, I was like, what is going on here? They're considering down negative, okay? But you still add the change. You always take the starting position and you add the change. So this would be 20 plus negative 16. What does that become?
Negative 36.
If they're both negative, you keep the sign like that.
Wouldn't it just be just 36 because 20 is bigger.
No, I mean, in a picture, in a graph here, this is ground level, this is 0. It's up here at 20 and it goes down 16. What's its new height?
4.
4, yeah.
Oops.
So there might be something there to look at with like adding positives and negatives. It's a thing that often gets overlooked and then never really learned, but we'll see. Always make sure you include those units there. So the next ones are also kind of odd because maybe if you haven't seen a scenario like this, a diver starts at 5 meters and changes minus 16. So this is 0. This is like ground level. Maybe this is water this time. They're 5 meters above the ground, but they're going down 16 meters. Where does that put them? It's always the start
Minus
plus the
11.
change. Yeah, so there's two answers. There's minus 11 meters, or you could say 11 meters below the surface. Is that okay?
Yeah.
All right. For part B here, and I think the picture is probably more important than anything else. I mean, here is 0. The whale is 9 meters below the surface. And then they change 11 meters. So they go up 11 meters. Where does that put them?
Uh, 2.
Yeah, it's 2 meters, or you could say 2 meters above the surface. Something like that. Any questions on that before we go to part E?
No.
Okay. All right, so part E, a fish swims at minus 9 meters and changes minus 11 meters. So they're here 9 meters below the surface, but then they go down another 11 meters. So it's minus 9 plus minus 11. What does that equal?
Minus 20.
Minus 20. Or you could say 20 meters below the surface. All right, let's look at number 3. There's a lot of words, but they're not actually relevant to what you're doing. They're just asking you in number 3 to add these together. So like the work here is, what is minus 6 plus 6? That's how they got 0. They're basically just saying add up these two numbers. So the next row would be minus 10 plus 10. What does that become?
0.
0. How about minus 10 plus 8?
Minus 2.
Okay, keep going, work on the rest.
Um, 2 for the next one.
Okay.
Mhm. 0.
All right, good job. So I'm not really sure. I mean, they're just trying to give you, like, I guess, an application problem of this. Not really sure. Okay, so to do number 4, we're going to just quickly talk about percent increase and decrease. So percent increase is always 1 plus the percent, and percent decrease is always 1 minus the percent. And then you typically multiply this by the original amount. All right, so that is because 4 is a multiple choice. Uh, we can sort of look at it as like which one is wrong or which ones don't work. We looked at this in a previous lesson, but there's a lot of words here. It says that the original price of gasoline was G, and that it increased by 5%. So it's this first situation. It's a percentage increase. They're calling the original G, and they're saying it's 5%, 1 plus 5%. So do any of these look like they could work?
Um, I'm gonna say like E and
E for sure, like that.
and C.
C for sure. Now there's one more, and it's B. The reason B is correct is because it's really 1G plus 0.05G, which if you add them together gives you 1.055G.
Uh,
A tough one to see.
okay,
All right, I'm going to just step away for 30 seconds. I'll be right back. You can start on N5A if you want. I'll be right back with you. All right, I am back. Um, 5A. It'd be good to do this one by hand. If you don't want to, that's okay as well. But it's important to line up the decimal when you're adding or subtracting.
hmm. Uh,
However,
I I got 43.6.
that is correct. All right, so for D, there's a couple ways to do B. I would recommend, and this is how they should teach it, is you first determine whether the answer is positive or negative. Do you know where the result is positive or negative just by looking at those numbers?
Uh, yeah,
Okay, so which is it?
negative.
It is negative. So we know the answer is negative. Maybe just make a note of that it's negative. Then you take the numbers without the sign and you subtract them, the larger minus the smaller. But you know the answer is negative, so whatever you get, you're going to put a negative in front. That's the better way. That's the better way to do it.
I got negative 4.8.
Yes. All right, good. So why don't you try, so for C, we were kind of dealing with this earlier. When they're the same sign, you keep the sign and you add the numbers. So you know the answer is negative, and then you just add the numbers as is without the sign.
Uh, minus 93.4.
Nope, oh, sorry, yes, sorry. I misspoke. I
Oh,
apologize.
minus. Why did I say minus? Sorry, negative.
No, no, it is negative. You can say either way. Um, all right, why don't you try D on your own, please?
I got 51.
It is 51, good. Right, let's try, some more of these positive negatives. Let's try this. Let's try a 4 minus 5 minus 3 plus -2. Could you simplify that for me, please?
Oh. Um,
And no calculator if at all possible. That would be kind of preferred.
so this is a whole equation.
Yep. This is just you simplifying this. Just want to see where you're at with, adding and subtracting things.
-6.
Yes. So this is -1 minus 3 plus -2. This is -4 plus -2. It is -6. Very good on that. So let me just put some. We don't have a ton of time left. Let me just put some various problems in front of you. These are all from 7th, 8th grade math classes. So um, let's see if you can tell me any of these answers. So your hint here is that there's a multiplication to go from 5 to 15. What do you multiply by?
What would X be 9?
It would be, yeah. All right, very good. Here's just another kind of thing to just see where you're at on stuff. Any questions on
Um,
this? Happy to
would it
answer some. Go ahead.
would it be -64?
Yeah, so the answer is, well, it's one or the other, right? Well, which one is it? So this really means -8 times -8. And what do you know about two negatives multiplied together?
Uh,
What's a negative times a negative?
a negative?
Positive. That's good.
Oh, yeah. Sorry, I was thinking of a negative plus a negative.
But let's say it's like -2 to the power of 3. This is -2 times -2 times -2. So these two give you 4. 4 times -2 gives you -8. What would -3 to the power of 3 be?
Um, 27.
Positive or negative?
Positive.
So -3 times -3 is 9,
Oh,
but then you're multiplying times -3. That
negative.
ends up
Wait,
being
is
27.
it? Yeah.
All right. So the idea here is that a negative number to an even power is always positive, and a negative number to an odd power is always negative. But maybe you'll see that in an upcoming class.